So today's first question, he has given that a ray of light has been traveling there, and whose refractive index he has provided is incident on a horizontal glass surface at an angle of critical angle. So it is falling at a critical angle conditions. Now, if a thin layer is being now poured onto the glass and air surface, the angle at which the ray emerges into the air at the water and air surface. That means, so for example, let us consider there is a glass surface of this sort of a thing is there. So whose refractive index he has given it as at 1.5. So this is a glass surface. So where the critical angle has been provided for them. So that means critical angle is equal to, so critical angle is equal to, that is sine inverse of 1 by mu, or relative refractive index. If I go more precisely, it will be the sine inverse of, so mu value is equal to 1 by 3 by 2, or this can be written as an sine inverse of 2 by 3. Okay, so this is the critical angle of the glass interface. Now on this one, what he is doing, some sort of an layer sort of a thing he has been pouring onto this one. So some refractive index he has been given as an refractive index he has been giving it as a 4 by 3. Then he is asking the what will be the critical angle for that particular situation. So now for this case, let us apply the Snell's law. That is from Snell's law, if I go for this one, from Snell's law, so we can write the mu1, that is the first refractive index of first medium, into the sine of angle of incidence in that medium is equal to mu2 into this is sine angle in that particular medium, that is sine r, or I can write it as a theta 1, or let me put it as in some theta 2. So now from this one, it is 3 by 2 into sine of theta c is equal to. So this is air interface, that is 1 into sine theta. So but in this case, what is the value of the sine theta c is 3 by 2 into 2 by 3 is sine theta. That implies sine theta is equal to 1. That means theta value should be equal to your 90 degrees. So this is a critical angle, or the angle at which the ray emerges into the air and the water surfaces. Now coming to the next question, an object is kept at a distance of 16 centimeters from a thin lens. So it is being kept at a 16 centimeters from a thin lens, it is there. And the image formed is a real image. Fine. If the object is kept at a distance of 6 centimeters, the same lens, the image is formed as a virtual image. Now, if the sizes of the image are being formed are the equal, that means height of the image in the first case, hi, in the first case is equal to the height of the image in the second case, where the virtual thing. Now he is asking the now he is asking what's the focal length of this one is going to be how much. So can we get the relationship between the magnification and this? So magnification can be written as an V by U. Okay, so this is a general thing. I'm going for this one. So V can be replaced as a 1 by F is equal to 1 by V minus 1 by U, or from this one 1 by V is equal to 1 by F plus 1 by U, or from this one 1 by V can be written as a U plus F by U into F, or from this one V can be replaced as an, so substitute here. So magnification can be written as an, instead of the V you can write it as an U into F by U plus F. Denominator is going to be the U, which is already this one. So your relation between the magnification and the focus can be written as an F is equal F plus this is relationship. Now in the first case, so what is in the first case? So in the case one, that is when U is equal to object distance is equal to minus 16 centimeters, then magnification M is equal to minus 1. So if I substitute, or else you can leave this one also, no problem, because the magnification general formula V by U in either cases, or this is the height of the image by height of the object. So in either cases, your denominator is same, and according to the question, it is being given in the worst case is equal to the, so height of the image in the second case by height of the object, where the height of the object is going to constant. So you can write it in this way, or else from this relationship -1 is equal to, this is f by f minus 16. Now let's go for the case 2, when object is going to be, that is u is equal to -6 centimeters. Then he is getting a magnification m is equal to 1, since the virtual and the inverted both on negative values will be cancelled. And by substituting in the formula, this we have got it from the m is equal to f by f plus u. Substituting in the same relationship, 1 is equal to f by, this will be the f minus 6. So these two should be same in this case, because their heights and everything are going to be the same, which implies minus of f by f minus 16 is equal to f by f minus 6. So from this one, if I go further, this one, remove this, and we can write it as n minus f plus 6 is equal to f minus 16, or from this one, 2f is equal to, so this is 22, or your focus f is equal to 11 centimeters. So this is what he has asked here. So f is equal to 11 centimeters. That comes out to be the option D. Next, coming to the, it's a question in the wave regarding the wave optics. In a YDAC experiment, Young's double slit experiment, the y coordinates of the central maximum and the 10th maximum are the 2 centimeters and the 5 centimeters in the sense. So suppose if I write like this is your screen, and this is your principal, the line which passes through both the slits. There is, and this is S1 and this is S2, both the slits. So there is an origin which is passing through like this. So origin is been passing through like this. That means your y coordinates. This is your origin. That means this is your x-axis, and this represents your y-axis. Here there will be the origin here, and center of the screen. That is your central maximum. So I'll mention this point as your CM. That is the central maximum, and that is the 10th bright fringe. That means this distance is going to be 2 centimeters, and this distance where the 10th maximum is occurring, this is at a distance of some 5 centimeters from the origin. Okay, so this is the information that has been given over here. So now this YDSC experiment is immersed in a liquid of the refractive index 1.5. So then what will happen? Then obviously the beta is going to be changed, or the fringe width is going to be changed. So that will come down over here. So now for this one solving, so for the central maximum, so let me name it as some CM. For central maxima, the n value will be equal to the 0. So that implies you can write it as n y naught into d by small d by capital D is equal to d sine theta. So these two things will be cancelled from this one. Sine theta can be written as n, this is y of the central maximum by distance between them. So y of the central maximum is 2 by d. Okay, so that means the your y naught, let me consider this YCM as in some y naught, and your y naught value is equal to 2. This is the main thing. Or 2 centimeters from there, or to whatever the thing given in the question, 2 centimeters. This will be the value of the distance from this distance of the central maximum from the, obviously this has been given in the question. Now let's go for, that is the 10th maxima. So for the 10th maxima, that is y of the 10 into small d by capital D is equal to, so this is small d into sine theta. So now, but this should be equal to the, because it's a maximum, it is 10 lambda. So that means this can be written as n So that means in this sense, this is 5 into, that is capital D by small d is equal to, that is 5 centimeters. This is given y of the 10th maxima is equal to 5 centimeters. This is given in the question. So the path difference between these two things, let me take here, since that is n is equal to 0 there, so this minus this. So that is path difference of the this one, and path difference is equal to 10 lambda. So y minus d sine theta is equal to, this is 10 lambda given in this case. So here y naught will be equal to the this one. So from this one, can we find the lambda value set? So sine theta value is equal to 2 into this one. So if we can replace this 5 into small d by capital D minus, this is 2 into small d by capital D is equal to 10 lambda. Or from this one, 3 into small d by capital T is equal to 10 lambda. Or from this one, lambda can be written as it is 3 into small d by 10 into capital D. I have got the value of the lambda here, please. This is your capital D. Now, for mu is equal to, if I take for mu is equal to refractive index 1.5. So for the central maximum, so y naught dash into small d by capital D is equal to d sine theta, where the y naught dash is equal to y naught, which is equal to the 2 centimeters. Okay, so this is the information that we have. So now this value is going to be the same thing, no change in this one. Now in the same case, if I go for the, so central maximum I have solved here, after it is immersed in some refractive index. So I'll solve here. So for 10th maximum, when mu is equal to 1.5 is there. So in this condition, what you can write? So y of the 10th maxima dash into small d by capital D is equal to, so else minus d sine theta is equal to 10 lambda by mu, that is 1.5. This is nothing but an n lambda by mu because it is immersed in some refractive index medium. So this can be solved it as an y of 10 dash into small d by, so capital D can be written as a minus, this is d sine theta is equal to 10 by 1.5, and your lambda value is going to be 3 into small d by 10. So these two will be removed. This will be 3 by 2, 3 cancels, and this will be equal to the 2d, 2 small d. And we these two with this is capital D, sir. And we know that sine theta value is also there. So from this one, y of 10 dash into small d by capital D is equal minus small d into the value of the sine theta can be written from here as n. The value of the sine theta is 2 by capital D. Here it is been, we have already got this one. So that is 2 by minus 2 by capital D is equal to 2 into small d. So now you can remove the small d on this side and capital D you can take it to the other side and solve. So on solving you should be getting the y of the 10th one is at a distance of 4 centimeters. So that means one is 2 centimeters, the other one is 4 centimeters. So this should be our answer, option C. And now coming to the fourth one. A particle is projected at a speed of 25 meters per second at an angle of 53 degrees with the horizontal in front of a inclined mirror. That means this is our mirror. So on an inclined mirror, it is been placed like this. Now he is asking what are the correct options in this case. So, okay, if I try to redraw the same diagram here. So this is our mirror. So which has been arranged at an angle that's at an angle of 37 degrees to the horizontal over here. This angle is 37 degrees to the horizontal, and it now there is another one. This particular point is projected at an angle of some 53 degrees. So, and this is 25. What is the velocity? Is 25 meter per second it is traveling. So, in that sense, there will be a perpendicular component for this one. Let this be our normal, and this is the perpendicular component, sir. So, obviously, this angle should be equal to the 37 degrees. Incidence is equal to reflection 25 things now. So, shall I go for this one as an horizontal components? That is horizontal velocity. Horizontal velocity is equal to 25 into this is cos 53. So cos 53 E is equal to the 3 by 5. So that will be equal to the 15 meter per second horizontal velocity of this source, whatever it may be. So now we will go for the vertical velocity. So vertical velocity is equal to, so you can write it as a 25 into this is sine 53, which is 25 into sine 53 is equal to the 3 by, sorry, this is 4 cos 53 and this is going to be your sine 53. So sine 53 is generally it is 4 by 5 and this goes for 5 times and it is 20 meters per second. So now when we go for the minimum speed, for the minimum speed situation, that is v cos 37 is equal to u cos 53. In the sense v into 4 by 5 is equal to u into. So this value will be equal to how much? This is in the sense which is 25 into 3 by 5. So then from this one we should be getting the velocity of the image as n v is equal to 75 by 4 meter per second. 75 by 4 meter per second. This is the condition. So next case, if I go for this one, that is V sine 37 is equal to 75 into 4 plus sine 37 in the sense 3 by 4. So which is equal to the 45 by 4 meter per second. 45 by 4 meter per second. From this one, V is equal to U plus 80. What I'm going to get this one is an velocity of the image only. This is 45 by 4 is equal to U in the sense that will be equal to the 25 minus 80. So on solving this one, you can get the time t is equal to 7 by 8 seconds. So they are been colliding. So on that sense, if I go this one, so velocity v is equal to velocity at t is equal to 7 by 8 seconds. That is the most important thing, sir. So from this one, velocity can be written as n v is equal to 25 into sine 53 minus gt. 25 into in the sense this is 45 by 4 minus gt. In this is the minus of 10 into this is time. And on solving this one, you should be given time that is t is equal to 7 by 8. On solving, you will be getting it as an 45 by 4. So this is the velocity, ma'am. This is the meter per second. Now the resultant velocity is of the image at some time t is equal to 7 by 8. So this is the condition, sir. So at the same time, if you want the velocity things, so v is equal to this will be the vh, that is horizontal component into velocity into sine 37 minus vertical velocity into this will be the cos 37. Okay, so now when you solve this particular thing, you should be getting it as an 15 into 3 by 5 minus 45 into 4 into 4 by 5. So which is equal to the, so the value of this one is 9 minus 9, that is equal to 0. So now what are the options here? The minimum speed of the object is equal to 0, and next one speed with respect to the minimum time, that is, it will be the 7/8 by 6. Okay, so these are the right now the right options for you. The speed of that object will be minimum after t is equal to 4 seconds. Let me check it out. T is equal to 2 into 25 sine 53. So which is e by 10, and which can be solved as, and this is 50 into 4 by 5. 50 into 4 by 5 by 10, which is equal to the 40-second session. This is the major 4 seconds, sorry. So now we can also go for the first option. That means A, B, C. You can go for in this case also. Okay, so next one. A convex lens forms an image of an object on the screen. The higher the image, 9 centimeters, the lens is now displaced through an image is again obtained on the screen. The height of the image is 4 centimeters. Distance between the object and the screen can be given as n. So he's asking the distance. It's a lens displacement method. Which method it is? Lens displacement method. So in this method, what we'll choose is we'll keep the source and the screen at the constant distance, which has been written as an L. L is equal to 90 centimeters. So now he is asking at 9 centimeters, we have seen the first image, and the 4 centimeters, we have seen the second image. So that means height of the object square is equal to height of the image 1 into height of the image 2. So L value we know. From this one, height of the object is equal to root over 9 into, so in this case 9 into whatever the value of this is 4. That means height of the image is equal to root 36, object is equal to, that is 6 centimeters. Now when we go for the magnification, M is equal to V by U. V by U is equal to, which is 3U by 2. V by U, so this is value is going to be the 9 we have got, and the velocity, initial velocity is 6. From this one, we can say that V is equal to 3U by 2. So V plus U is equal to D. From this one, V plus 3U by 2 is equal to D. That is the distance between the source and the screens where you are getting the virtual image, two images. So from this one, so both of them are going to be the, this is U and U only. We have replaced the V with these things, please. So from here, uh, that is V plus this one. Okay, so V is equal to, we can say that 3U by 2 on cancelling the D value also. So we have got this relation, but V plus U is equal to D. From this one, I can say that U plus 3U by 2 is equal to 90. Or from solving this one, U should be equal to the 36 and V is equal to 54. Right, so this is the, and from this one, he has also asked the focus. F is equal to 36 into 54 by 90. That is, the focus comes out to be 21.6 centimeters. So this is your focal length. Both of them he has asked. D is equal to, and this is the one. So now what will be our answer, sir? So finally we have got it as an U is equal to 36 centimeters and this one. So where it is, so 36 centimeters, this is the one of them is going to be the correct. And B value we have got it as the correct, sir. That is this particular thing. Sixth question we have. So B is correct and as well as the D is correct. 21.6 exactly we have got it. Now a convex lens of the 40 centimeters is held at a distance of 12 centimeters coaxially above the concave mirror. This is your concave mirror. Exactly at 12 centimeters, he has placed this particular lens, focal length 18 centimeters. Now a luminous object is placed at a distance of D centimeters above this one. So here he has placed an object. The rise to the image coincidence myth itself. Then what is the value of the D? Okay, so now What is the condition here? The luminous object placed at the D above the lens, its axis gives the rise in the image coordinate itself. Value of the D he is asking. Now, the rays must retrace their path, and after the reflection, whenever the light ray is going to be coming, it's going to be obviously bent by certain angle. Then retracing should will also be there. So let's see. So when it has been happening, or when the retracing has been happening, or the reflection has been happening, the image obtained from the convex mirror lies on the radius of curvature. That means on this line. Most of the engineering buses will be on this line. So image formed first refraction from the convex lens must lie on it. So the radius of curvature we need. Next, how can we proceed this one? Hence, that is distance, image distance from lens, image distance from the lens is equal to radius of curvature minus 12, or from this one 2 into 18 minus 12. So this is equal to the 24 centimeters. So this should be our basic thing, sir. From this one, if he is asking the d value, that is 1 by v minus 1 by u is equal to 1 by f minus 1 by 24 minus 1 by d is equal to 1 by 40. So from this one on solving, you should be getting the d is equal to 15 centimeters. So this is the only value that is going to be existing here, 15 centimeters. Seventh question is a continuation question of the above question. Now he is asking if the focal length is going to be 60 centimeters. What is the value of the d? Same relationship, that is minus 1 by 24 plus minus 6 minus 1 by 6 is equal to minus 1 by 60. So now the focal length is being changed to the 60 centimeters. Then what can he is going to be the value of this? So that is d value is going to be how much? So from this one, minus 5 plus 2 by 120 is equal to 1 by d. Or from this one, d is equal to 120 by 3. In the sense, this answer is 40 picofarads. Okay, so this is the condition. The value of the d he has given, that is a 40 centimeters, which is equal to the 40 centimeters. This is your option C. Now coming to the eighth one. A container of uniform cross section is there, and it is at a height of, this is the let us consider an container here, which is of uniform cross sectional area, and this distance is 14 centimeters. Now when he is filling the water up to some refractive index, he has been refractive index 4 by 3, inside the conductor seems to be half filled in the normal way. That means he is looking, he is seeing along with this line. So we cannot have the this thing half filled means, that means it might be, you might be observing from some other place here. So then he is asking what are the different things. So in the sense, the length of the, that is d apparent, that is apparent depth is equal to d real by x. So real distance by x, real distance also we don't know. This is x by lambda is dpp. From this one, x is equal to lambda into d lambda into d apparent. You can write it. Or else we can solve this one in the x by lambda. From this one, we can say that x by whatever the value is there, that is lambda is equal to, find first, that is x by mu, we can write it, which can be written as an x by 4 by 3, which is 3x by 4. Now the length of the air column is, so this one, length of this one is equal to the not length of the column, or length of the air column is equal to 14 minus x. So we can equate these two things, that is the real and apparent conditions, that is, which will be the 3x by 4 should be equal to the 14 minus x. From this one, 7x by 4 is equal to 14. This is 7x by 4, which is equal to the 14 centimeters, in the sense x is equal to 8 centimeters. So this is the condition. So next one, question number 9. A thin lens is coated with a film. That means there is a lens which is called as an convex lens. Then neither on that thing, A thin boy is being coated on this one. Okay, this has been completely coated with a black surface. So this particular thing, or you can call it as a silver thin conditions, which has been covered up over there. Now for this one, if a light ray is going to be coming and how hitting this particular surface, then what should happen? There should be already a phase difference of 90. So now on that sense, if I go, that is path difference is equal to lambda by 2. This is 2 mu 1 into t minus mu 2 by is equal to mu 2 by or lambda 2 by 2. Or simply you can erase this one lambda by 2. So from this one, we need the thickness of the film T is equal. We can put it as, we can maintain it as n T is equal to somewhere around lambda by 4 into mu 1. Lambda and this is 4,800 angstroms by 4 into 1.2, which comes out to be the 1000 angstroms. So T is equal to 10 to the power of minus 7 seconds, or time T is equal to 0.1 into 10 to the power of minus 1 seconds. So this is the time taken. So what is the reflection? 0.1 seconds. Next question number 10. The YDSC experiment slit is being pointed, yes, slightly of the central axis. Lambda is equal to 500, match the following. So now if this is going to be happening, or if you are being, so from here the source is there. The time taken by this source from the light to reach to this point is going to be that the point P in this direction, and from the S2. From further S2, we have to go for this is the one light coming in this way, and it is being reflecting on this one. 1 second. Yeah. So this is how the light is traveling to reach to the point P. So now what is the path difference here? So let's first find it out with the path difference. The path difference is equal to lambda by 2. That is 2 mu-ish. 2 into mu1 into t is equal to lambda by 2. From this one, t is equal to lambda by 4 pi epsilon naught. This is going to be the R 4 epsilon 1. So what is the lambda value is 4,800 by mu value is that is t into this we have written lambda by 2. So t value written 4,800 by this is 4 into 1.2, which is equal to the 1000 angstroms. So from this one, time t is equal to 10 to the power of minus meters, or this can also be written as n. So we have got the part difference over there, right, sir? So now coming to this one, all this information, let's do it in another different way, where it will be the most comfortable things. We need to match them. That is a very important thing. So in this case, the path difference again, I'm going in another way. That is path difference is equal. So path, what is the path difference value is? That should be equal to the difference is equal to 2 mm into 20 mm, 20 mm by 1 m. So which is equal to the 4 into 10 to the power of minus 5 meters. Minus 5 meters are in on this case, this is the value. We have got the path difference, or this is your delta x value. So for the same case, the path difference is path difference at that point is equal to x into d by capital D plus this extra path difference 4 into 10 to the power of minus. So which can be solved as x value is 10 mm, 10 into 10 to the power of minus 3, 20 mm, 20 into 10 to the power of minus 3. Now give me remaining is 2 m. So when I plus 4 into 10 to the power of minus 5, which comes out to be the 1.4 into 10 to the power of minus 5 or minus 4 meters and GPUs. So now this is the 1.4. So at this 1.4, if I want to write this one in terms of the lambda, that it will be the 8 lambda. So that means you can go for the first option here. So 1 should be related to whom? D. So in this case, this is the one. So why 1 should be related to this one? The value of this can be written as, and this is 280 lambda. 280 lambda. Fine, sir. This is the first one. Now coming to the path difference at point A. Path difference at point A. So A and A point path difference also. So how do you get this one, please? So now for that one, part difference at the O and part difference at the A, two things we need to get in. So for that one, when this will be after introducing film. After it introduces this particular thing, then part difference is equal to T into mu minus 1 is equal to 9 into 10 to the power of minus 6. From this one, T is equal to 8. This is the relation. So T is equal to 18 lambda, or the thickness. So from this one, we can say that the path difference at O is equal to the, so that will be equal to 200 and the same thing, which can be expressed as some 262 lambda. So now 200, 262, that means at the O, we'll be getting at O, we'll be getting it as a 98 alpha and 62 alpha. So these are your corresponding things, sir. Now when you match it up, so first one is match it to the D. So one is match it to the D, and the two should be matched to the, that is nature and order of the interference at the point O. So that means 2 can be related to this one, that is 2 is related to the A. So next case, sir, in this, the thickness when introducing at one side, this is nature and order of this one. Okay, so on inserting the transparent paper, he is saying. So that means third should be related to the B thing. As we have solved that one, that is 262, you should be getting. Obviously, fourth can be related to C. So these are the things. So one, it is in the form of 1D, 2C. So in that sense, it will be, this is this case, 1D, 2A. Okay, that is the best thing. So in the next case, please. So by this question, we'll be completing the today's session of the rise on the topic of the optics. Hope everyone has enjoyed this one. All the best to each and every person who is attending this.